In the previous video, we already saw all of these laws. These laws has been discussed about these laws. We already discussed about these laws. These two laws already done. But now we are going to see this law, this flowing law. Let's go. Let's start with this question. In solving, we simply apply this law. We simply apply this law. Let's apply this law. You see, these exponents operate on this basis and we both done, just done. Question is already done. Now question B. Question B. We also apply this power of power rule. These exponents operate on both these bases, operate here, and then the second step this is the following step: 2 to the power 3 here and then here. Now the last step is one. See, this is the last step. Here I expanded this power to get 8. Now question C. We know every number exponent is 0, we go to 1. It's a rule. We are going to see in the following the following sense. Now D, let's solve D. In D I apply this loop, this one, this loop will be applied. That's why I multiplied the exponent. Here we have already exponent 2. Now we multiply the exponent. This is a rule of power of powers. And then the final step is as follows. This is the final step here. This was the question number A. We already solved it with this problem. A, B, C, D. Now let's jump here. Is the following question. A. Here we apply this law. By applying this law, you see, you get here 9 over 20 5 like this. Already done. Question B. Also apply the same law here, and we get x to the power 5 over y to the power 5. Good. Now let's solve this problem. Here apply this law, this one, then apply this exponent here, exponent. Now last step, you see, 2 is number 2, exponent 2 operates, is distributed over to the basis here under the parentheses, and then the final answer is this. Option B here. See, same law. These 2 was here, this, this. And then you see that the final answer is 2 x and m to the power 2 square, m square. Now see, I first applied this law. I first applied this law. This one, this exponent operate here. That law is applied the first way, and then 3 times 3 we got 9 like this. At this step we apply the division law of indices. When we have the same base, the exponent must be subtracted like this. See, like this. See, good. Now let's come back here. The last step we get this. The final answer is this one. Okay. Now D. See D. In solving this question, we apply firstly this law, this one, this 5 is going to operate here. Then the last step is this one. The last step. With this solve the problem, it is easy to solve. It is easy to solve all of this problem. Now let's jump here. Solving this problem, we applied the same rules. This half will operate here, this multiplied, then final answer is 6. B is like A. B is like A. We applied always the same way. This half, this fractional exponent will operate like this. We used this law here, x. See, this law will be applied. See, this law will be applied. See, x times y. Then I applied it here, then because we are told to evaluate, I evaluate the value of the power with this one. Now the next problem is C. Solving the problem number C. See here, we apply which law? This one we saw in the previous video. That video is already on our channel. This law has been applied in solving this problem. Please see, solving this problem, and because you see, when we divide the same power, the exponents are subtracted. Yes. Let's skip this problem and solve this, because it's easy to solve this one. Let's solve this. I skipped this one. Now solve this. It's very easy to solve it. Very easy to solve it. Now see, this is an improper fraction. I convert it. These are mixed fraction. I first convert it into the improper. You see here, and then I applied the law of the power. And the final answer is as is. Here we are asked to write with negative indices. Write the following with negative indices. Now let's start with this one. We are going to write with negative indices. In writing these with negative indices, we simply apply the law we saw previously. See this one. This will help us to write as negative indices, because when you have think here under the fraction bar, go above the fraction bar with the negative sign. Now let's see how to work. See here. See, I go over the fraction bar with negative sign. We applied this law, simple law. Just see, I go over the fraction bar negative, and see, this law has been applied. Good. Now let's solve B. Let's done. B is like A. It's very easy to solve all of these problems. Easy. Simply to write with negative indices. Very easy. Very easy. Easy. Seriously. See. Very simple. Very simple. Very simple. Now, as it is simple, let me jump through here, and I skipped this one. This C, D, A. I skipped them because they are already discovered how to solve. I skipped them. It's left to you. The solution is left to you. Good. Now F here. Let's solve F. Okay, now like this. Very easy. We are asked to write with negative indices, only negative indices. That is, see, negative indices. Good. Just now let's solve this next problem. This, if x is greater than 1, which is greater, x or x squared? If x is greater than 1, which is greater, x or x? Good. The answer is simple. X squared is greater than x. Let's explain this concept. Explanation. Let's explain you. This. Suppose that x is equal to, then x squared is 2, exponent 2 equal 4. But 4 is greater than 2, hence x squared is greater than x. Here you suppose, or you take any number of your choice and you compare only. Take any number of your choice and compare. Just, it's like 7. If 0 is if x is between 0 and 1, which is greater, x or x square? Let me show you. Number 7 here. Let me show you. Shit. X is greater than 2. In this case, why? Let me explain you in a Kinyarwanda somehow, so that you can understand very well. Barakubwiye bati x iri hagati ya 0 na 1. Imibare iri hano muri iyi set cyangwa muri ensemble, muri no intervalle, ni imibare y'imigabane, aho numerator aba ari ntoya kuri denominator, like this. Iyi niyo mibare iba hano, ni imibare y'ibice twita rational number or set of rational numbers. Gutya. Ubwo rero ugomba iyo mibare ugomba kuyandika gutya. Ni imibare yandikwa gutya. Imibare yandikwa gutya niyo ibelonginga muri iyi interval. Ako kantu ugomba kubanza ukagashyira mu mutwe. Tagenze gutyo ntago wabyumva. Which is greater than. Nimba uko bimeze rero, reka dufate 2. Fata urugero 2. Ubwo nufata gutya over 2, ugafata na gutya over 2, urayigira square gutya, kuko ubwo mfashe gutya na gutya. Ayabonye mpamvu mbyanditse gutya nuko batubwiye ni imibare iri hagati ya 0 and 1 muri no intervalle. Ngaho noneho hano shyiramo 2, x isimbuze 2, urebe right, ubona 1 over 2 and a quarter, a half and a quarter. As we know, iki nicyo kinini. Urabona iki nicyo kinini, kubera ko iyo numerator zingana ni imigabane, comparison of fraction. Iyo numerator zingana, ikinini ni kiba gifite denominator ntoya nyine. Iki nicyo kinini, niyo mpamvu hano akwaje ngo which is greater, x or x square. X niyo greater than x square rero, kurikije ibi byose tumaze kuvuga. No mpamvu byose nabigushyiriye hano kugira ngo mubone, sino ntago wakumva kakabazo. N'indi concept yo kumenya amaset. Iyi ni imibare yawe hano, mbanze nkwereke. Aha dore iyo mibare iri hano, no kuri step mpita nkubwira ko x nuvuga ko ingana na 2, umubare mpisemo wari wose ni washyiramo 3 washyiramo 5 kabigereranya. Rero tubona ko x ariyo nini, ari greater than kuri x square mu gihe baduhaye ino interval. Ndashaka cyumvika inako tugiye gukora iki ngiki cya 8. Byose ni kimwe. Reka nkwereke ukuntu hano iki cya 8 rero cyo tugiye kugikora. Kubanza sibe bine cya 8 byose ni kimwe, n'ukumenya iriya concept gusa. Look at the answer. The answer is like the previous. Now we use the same concept as the previous problem, only arranging in ascending order, or from the small to the big. It's like that ascending order, because putting that all, say this. Good. The same concept. Now let's stop by here. See you in the next video. We try to use both languages, Kinyarwanda and English. Thank you for watching.